Hornets, thank you for joining me. I'm going to be going over the sum identity for x plus y, which I had a problem and I accidentally screwed up on in fifth period, and I wanted to make sure that everybody had the correct proof, even though you don't have to do it. All right, it's still important, and I think it's valuable. Now, we start off with this wonderful picture where I have two angles. Angle Y is angle BAC, and angle X is CAD. Now, in order to do this, I'm going to make sure that I claim that this length DA is 1. I'm going to also make sure that I draw an auxiliary line straight down so that I have a right angle, and I'm going to just call this point right down here F. Now, once I have that, I need to draw another line, and I'm going to go ahead and I'm going to draw a right triangle right here. Okay? Now, you'll notice I now have two right triangles. I know what this right triangle is, and therefore, from angle X, I can say that the opposite angle is or the opposite side DC is the sine of X divided by 1. And therefore, I know that this is the sine of X. Cosine of X is therefore going to be AC. And I know that the cosine of X is going to be AC divided by 1, and therefore AC. Next, I'm going to go ahead and I'm going to look at two parallel lines. These two lines are now parallel, cut by a transversal. That means that I know that this angle is y, but you'll notice it formed a 90-degree angle and is therefore complementary and has to be 90 minus y. If this is a right triangle, then I know that this angle up here has to be y because the two acute angles of a right triangle have to be equal to 90 degrees. If I then draw an auxiliary line down here called CB, it also is a right angle. And if I locate this point right here and call it E, EF has to be congruent to CB. So I now have a complete picture. I can see where I have various pieces, and I'm going to go ahead and start. If I have the sine of X plus Y, it has to be the entire segment DF. I also know that segment DF, the way I have broken it up by segment addition postulate, has to be DE plus EF. I also know that by substitution, my EF, let's start with two parallel lines and a rectangle. Opposite sides have to be congruent. So EF has to be equal to CB. But notice, from angle Y here, my opposite side CB has to be the sine of Y if I divide CB by the cosine of X. See how the sine of Y is my opposite side over the hypotenuse? And therefore I can say that CB is the sine of Y cosine of X? What else can I say? Well, let's think about our segment DE. See how DE is right here? From angle Y, I can have EC, segment EC, is going to be divided by sine of X, and this has to then equal the opposite over the hypotenuse, and I know that it has to be the sine of Y. Let's see, what else can I say? So I have EC, I have, let's see, DE. What's DE? Well, DE would be the cosine, wouldn't it? So DE divided by the sine of X is the cosine of Y. Now that means that there are two things. I know that EC, for example, simply by multiplying by the reciprocal on both sides, is the sine of x sine of y. I also know by the same reason that DE is going to have to be the sine of x times the cosine of y. Alrighty, let's now see what we have. We know what DE is, okay, and we know that CB is this. So if I take DF and I do direct substitution with CB and EF, I have DE plus CF, DE plus CB. But I know that DE is cosine sine, so I'm just going to put that sine of x, cosine of y in, and then I'm going to make sure I arrange it so it's got the same order. Therefore, I have cosine of x, sine of y. And now I can go back and I can substitute df with the sine of x plus y. So I have the sine of x plus y has to equal the sine of x cosine of y plus the cosine of x sine of y. And this is the identity that I was trying to show you today in class. Once again, based upon these right triangles and what I have. So, looking at angle y, I have the sine of y is CB divided by cosine of x. From this triangle, I have, DE. So the cosine of DE of y has to be DE divided by the sine of x. And therefore, I end up with this piece and this piece. By substitution with EF and CB, I end up with this. And then I can directly substitute each of these pieces that are circled and then DF with the original to get my identity. This is the proof for the sine of x plus y. I hope this was helpful. I hope it made more sense than what I did in class, and I hope you can see what I was trying to get at. Once again, I hope this helped. If you like it, please make sure you click like. If you think there are suggestions that I can improve on, please feel free to give me your suggestions. Thank you very much, Hornets. Have a great night. Cheers. If I can stop it. I am attempting to stop it. It will not stop. I can't get it to stop.